All right, well, welcome back. Here we're going to look at another example. Again, each situation is going to be different, so we want to be just really careful in our setup and see what we can do here. So, forgive me for that pronunciation. Unzen and Chichiwa. Here we go. The Unzen volcano in Japan has a magma reservoir that is located beneath the Chichiwa Bay. The magma rises eastward at an angle of elevation of 40 degrees for 25 kilometers. How far below sea level is the magma reservoir? Magma reservoir. Ooh. Okay, so they've already started us a little bit of a drawing, trying to help us out. In the future, maybe we'd have to do all this ourselves. First thing we want to notice, we have an angle of elevation of 40 degrees. Is an angle of elevation from the ground or from the sky? It's from the ground, and then we elevate it. So we'll go up. So we're looking at 40 degrees from here to here. Okay? So you might recall from doing right triangle trig that we need one more side, and then we can figure out any side that we want. So in this situation, we're given another number here, 25 kilometers. It would make perfect sense to put it here. It would make perfect sense to put it here. It would make perfect sense to put it here. Would you please do your best to tell me where this 25 goes? It says the magma rises eastward at an angle of 25 kilometers. Okay, it is the hypotenuse, it is this side. And now we need to determine what we're looking for. It says, how far below sea level is a magma reservoir? So here's sea level, you can see the water there. We want to go down, so we're interested in how much this is. So that's going to be what we're trying to find. Now I would like to just point out that I give you the exact same problem. It would be said the exact same way if I said that the angle of depression from the sea level to the magma was 40 degrees. And that would give you the equivalent triangle. But we'll go with what the words are here. It says angle of elevation, so we'll do that. Some people like to redraw the triangle. Some people, they're happy with how it looks already. Doesn't really matter. We go to the 25, we go to the 40 degrees. We're looking for x. We're looking for the right trig function. And then the correct algebra. Hey, all right. So, do I take the perspective of the 40 degrees? Do I take the perspective of the 90-degree right angle? Never take that. Or do I take the missing 50 degrees? Who do I use? We're going to use the perspective of the 40. From the perspective of the 40, the 25 and the x need to be O, A, and H. I guess we'll go with the opposite cross, the hypotenuse across from the right angle. This would be the adjacent. You can tell that we don't have the adjacent here. The correct trig function is going to be sine, because sine goes with O and H. So sine of 40, 25, or x. It's always of the angle. So whether we know it or don't know it, it's always the trig function of the angle. So sine of 40 equals x over 25. Would you please pause the video, do whatever algebra you need to do, and then tell me the correct answer. And let's go with 2 decimal places to the nearest hundredth. Please pause the video and resume when you're ready. All right, welcome back. The correct algebra would be to multiply both sides of this by 25 to end up with an equation that is 25 sine 40. And that's what x equals. So once we punch this in our calculator, we're going to lose some value. So I'm going to go ahead and start with my approximately. And if I do 25 sine 40, I'll get an answer of 16.07. We should include units. These are going to be 16.07 kilometers. If you're one of those people that likes the variable on the left, you might go with that answer. Doesn't really matter. All right? So, hey man, it's like 10 miles below the sea level. this reservoir is. Let's go ahead. You have questions on how we did the right trig function, or you have any questions about how we did the correct algebra? Questions about that? All right, let's go ahead and move on to example 3. This is one of my favorite ones. Every year, it's one of my very favorite problems. I should have left that. Every year, one of my very favorite problems. We've got that Austin is standing at the high dive of his local pool. 2 of his friends are in the water at the opposite side of the pool. If the angle of depression to the closest friend is 40 degrees and 30 degrees to the other friend, and the diving platform is 9.3 feet tall, then how far apart are Austin's friends? Okay. So this brings in this scenario. This is kind of a thought bubble. So here's the water, here's the person that's up on the platform, and they're looking down. Let's make this really exaggerated. And we really spent a lot of time in class talking about how everything isn't drawn to scale. This is one of those things that you're definitely going to want to use your brain and decide which of these angles has to be bigger, where I have angle 1 or where I have angle 2. If I'm looking up toward maybe like the flag in this classroom, as I'm far away from the flag, I've got a pretty level posture. My chin's fairly level. But as I go closer and closer, the angle I have to make to see the flag increases. So angle 1 is bigger than angle 2. Okay? Now in our problem, we're talking about angles of depression. And so I've already drawn these that they're angles of elevation. What we need to see is that from the sky, it is 30 degrees here, and it's 40 degrees here. And that's going to mean that angle 1 is like 40, and angle 2 is 30. Okay? So let's go ahead and get this one set up. The triangle, a 9.3 for the height. We've got, I like to use a couple of different variables here, so I'm just going to draw this first. Hopefully you see one right triangle and a second bigger right triangle, and you'll see this triangle on the right side. It's not a right triangle. It's definitely a triangle, but it's not a right triangle. We're going to fill in our 40 degrees here and our 30 degrees here. And my question for you is, do we need to know this distance, how far it is from Austin to this closest friend? Do we need to know how far it is from Austin to his friend that's further away? Or do we need to know how far away the friends are from each other? We need to know how far his friends are from each other. In order to get that, so this is what we really want to find. This is x. We don't know this. We'll go ahead and call it y. Second period students, I switched y and w in your problem, so if you're watching this again, that'll help you out. So from here to here is y, from here to here is x, and then I'm going to use w for the whole thing. So w is this whole distance here. So my end goal is to get x, but I'm going to have to get w and y in order to access what x is. X is going to be w minus y, the whole thing minus the part I know. We'll pick up in just the next video about finishing this problem off. I'm going to draw 2 right triangles. I'm going to figure out what each w and y are, and I'll plug it in and figure out what x is. Try to get example 3 and example 4 done for you in just a few moments.